This is my intermediate algebra course. Today we're going to learn more complicated logarithmic equations. If you haven't done the homework completely and correctly from last class, do that homework before watching this video. Okay, here's the exponent rules. You should have these on your phone or on your computer by now, but you can take a screenshot of those if you need to. Let's first do a little review. We've been solving logarithmic equations, but again, we're just going to go into more complicated equations now. But before that, remember, in order to solve a logarithmic equation, you have to convert to an exponential equation. And remember, this little number here, that's always the base. And whatever the logarithm is equal to, that's always the exponent. And whatever's in the log function, that goes on the other side of the equation. And so 2 to the third power is 8, and we have our answer. Here's another logarithmic equation. Again, this small number here, that's always the base. So we write our base. And whatever the logarithm is equal to, that's always the exponent. And whatever's inside the log function, that goes on the other side of the equation. And we found x squared. Problem is we don't want x squared. We want x. So we're going to have to get rid of that 2 power, or the 2 exponent. So we do the opposite of squaring, which is square rooting. And because it's an even power, remember you always have to write plus or minus with even powers. So we have x is equal to plus or minus 5. So we have 2 answers, x equals 5 or x equals negative 5. The problem is, remember, traditionally you're not allowed to have a negative base inside a log function, and you're not allowed to have a negative in the log function itself on either of those numbers. So x equals 5 is not a solution, so we won't rectangle that, but we'll rectangle 5. Again, we're just reviewing the basic idea of how to solve a logarithmic equation. So here's one more we can do before we go into some more difficult equations. So the base is always that small number. The exponent is what the log is equal to, and the other number goes on the other side. And so now we want to get the same base. 27 is 3 to the third power. So now we have the same base, which means that because the powers are equal to each other, the only way that that could possibly work, the only way the equation could be true, is if x is equal to 3. So again, this is just all review. In order to solve a logarithmic equation, you must translate the equation to an exponential equation. And then you can use that equation to solve. So we've done quite a few logarithmic equations, but again, we're just going to go into some more complicated equations. It says solve and write the Roman numeral of each exponent rule that you use. So again, you can take a picture with your phone. You should already have these by now, but we're going to need those Roman numerals. And so now we have another logarithmic equation, and we're going to solve it the same way we solve the other equations. We cannot solve this unless we translate into an exponential equation. So what is the base? Well, the base is that small number there, as usual. And the power, or the exponent, is whatever the logarithm is equal to. And whatever's inside the log function, that goes on the other side. Again, translating back and forth between a logarithmic equation and an exponential equation. And the other way around, exponential equation to logarithmic equation, that's the most important thing to understand about logarithms. If you can't do that, then there's no way that you're going to be able to understand this part of the course. So 3 to the second power is 9. And you can add 6 to both sides, divide both sides by 5, and we get x is equal to 3. You can do those steps in your head if you want to, because that's just a two-step equation. We learned how to do that in pre-algebra. So what's different about this equation is that what's inside the log function is a little bit more complicated, but it's really not, much more difficult, as you can see. Let's do some more of these problems. So we want to translate to an exponential equation. 4 is the base. Whatever the log is equal to, that's the exponent. And then whatever's inside the log function, that goes on the other side. Now at this point, we do have to use an exponent rule. This is rule number 6. And so 4 to the 1 power, anything raised to the 1 power is just whatever that number is. And now we're going to subtract 5 from both sides and multiply both sides by 3, and we get x is equal to -3. Again, you can do multiple steps in your head if you want to. Again, if you have to show every single algebraic step, it gets kind of tedious after a while. This is upper mathematics, intermediate algebra, so some of the stuff you learned in beginning algebra you can do in your head. You don't have to show every single algebraic step, but you do have to show some work. Okay, so let's do a couple more of these before you try some on your own. So again, we cannot solve this logarithmic equation unless we convert to an exponential equation. The base is that little number, and the exponent is whatever the logarithm is equal to, and then what's left over goes on the other side. Now we have to use an exponent rule. That's rule number 7. Rule number 7 tells us anything raised to the 0 power is just 1. It's always 1. Subtract 7 from both sides, divide both sides by 6, and you get -1. So x is equal to -1. Okay, let's try one more of these before you attempt some on your own. So again, we're going to convert to a exponential equation. We have our base, we have the power, which is what the log is equal to, or the exponent. You can call it a power or an exponent. Remember, technically the word exponent is the more accurate word to use. So now we have a negative exponent, so we're stuck. We can't do anything unless we translate that using exponent rule number 8. That tells us that a negative power just becomes a fraction, and 3 to the 2nd power is 9. Now at this point we have to do some arithmetic, and a lot of students don't get very good instruction with arithmetic, or maybe you did get good instruction but you just forgot. But we have to do a lot of arithmetic here, and because this is an intermediate algebra course, you're required to know how to do this on your own without anybody telling you. Most intermediate algebra teachers are not going to show you how to do this. I'm going to go ahead and quickly show you how to do this. We're going to subtract 5 from both sides, obviously, and when you have a whole number you're subtracting from a fraction, you write that whole number as over 1. But we cannot subtract fractions unless we get a common denominator. So remember the fundamental principle of fractions. You can multiply both sides of a fraction by the same number, and the fraction remains the same value. So 5 times 9 is 45, and 9 times 1 is 9. And now that we have a common denominator, you can subtract these. You just subtract the numerators. 1 minus 45 is -44. And there you go. -44 over 9. So we get -44 over 9 is equal to -x over 4. And now we're going to multiply both sides by -4. And so when you do that, again, you write the whole number over 1. And it's probably best to use parentheses rather than a dot. So when you multiply fractions, you just multiply straight across. -4 times -44 is 176, and 1 times 9 is 9. And obviously a negative times a negative is a positive. So 176 over 9, and want to try to keep the equal sign lined up if we can. So now it's time for you to try. Try number 5, and when you come back, we'll do it together. All right, we're back. So we need to convert this logarithmic equation to an exponential equation. So the base is 3. The exponent is what the log is equal to, and everything else goes on the other side. 3 to the 4th power is 81. And add 1 to both sides, divide both sides by 2, and we get 41. So if you got that answer, that's very good. Good job. If you didn't get that answer, that's okay. Just go back and figure out what you did wrong. All right, go ahead and try number 6, and when you come back, we'll do it together. All right, we're back. Again, we need to translate to an exponential equation. So we have 4 to the 0 power is equal to x over 7 plus 8. And anything raised to the 0 power is 1. That's rule number 7, exponent rule number 7. And then we subtract 8 from both sides, multiply both sides by 7, and we get negative 49. So if you got that answer, good job. All right, try number 7, and when you come back, we'll do it together. All right, we're back. We need to translate to an exponential equation. The base is 9. The exponent is what the logarithm is equal to. And what's in the log function goes on the other side. We need to use rule number 6, which tells us anything raised to the first power is just whatever the number is. And add 2 to both sides, multiply both sides by 3, and x is equal to 33. So if you got that answer, that's very good. Good job. All right, try number 8, and when you come back, we'll do it together. All right, we're back. We need to translate into an exponential equation. The base is 2. The exponent is what the logarithm is equal to. What's in the log function goes on the other side, and at this point we have a negative power, so we can't really do anything with that. We're stuck. Unless we use rule number 8, exponent rule number 8, which tells us that that power becomes a fraction. And now we have 1 over 8 is equal to 1 plus x over 5. Now again, sometimes you have to do basic arithmetic. We're going to subtract 1 from both sides, so we get 1/8 minus 1. Well, how do you deal with that? Well, you turn 1 into 1 over 1. Remember, you can write any whole number as over 1. And at that point, we're subtracting fractions. Well, how do you do that? Well, we learned that in previous courses. You just get a common denominator. You can use the fundamental principle of fractions, multiply both sides by 8, and that gives you 8 over 8. So we end up with 1 over 8 minus 8 over 8. So now that's like 1 sandwich minus 8 sandwiches gives you negative 7 sandwiches. I know that there's no such thing as a negative sandwich, but you understand what I'm talking about. That's why you have to get a common denominator, is because you have to subtract the same things. You can't subtract an orange from an apple. That doesn't make a lot of sense. But you can subtract an apple from an apple. Okay, so when you subtract 1, you get negative 7/8. And then when you multiply both sides by 5, you get negative 35 over 8. And sorry, we kind of ran out of room down here. So if you got that answer, good job. Again, remember, when you're multiplying a whole number by a fraction, you just multiply straight across. 5 times 7 and 1 times 8. All right, so again, if you got that answer, good job. So now we're going to do some slightly more difficult problems or more complicated problems. They're not really more difficult, they're just more work. So in this equation, we first have to isolate the logarithm. It's very important to understand that in all the previous problems we did, the logarithm was already isolated. You see, for example, in this problem, the logarithm is by itself on one side of the equation. There's no number multiplied into here or added over here. You know, the logarithm is by itself already, so it's already isolated. But in the problems we're about to do, the logarithm is not isolated, and so you can't solve this equation. So we have to isolate the logarithm first. We have to get it by itself on one side of the equation, which means that we have to get rid of the 2 and the -6. All right? Just like we solved equations with square roots, you have to isolate the square root. Or equations with absolute values at the very beginning of the course, you have to isolate the absolute value. Or exponential equations, you have to isolate the exponential expression. And there's probably other examples of that I can't remember, but there's a lot of problems where you have to. Another example is isolating equations with isolating the square in equations with squares. A lot of problems where you have to do that. So we're going to add 6 to both sides. And then we're going to multiply both sides by 2. And now we've isolated the logarithm. All right, so the logarithm is now by itself. And so now we're going to translate into an exponential equation. The base is that little number. The exponent is what the logarithm is equal to. And so we get 36 is equal to x over 3 minus 4. Add 4 to both sides. Multiply by 3, and we get 120. So the problem is not really that much more difficult. It's just more involved. All right, so let's try number 10. We first have to isolate the logarithm, which means we have to get rid of the 2 and the 7. So we're going to subtract 7 from both sides. And then we're going to divide both sides by 2. And now we've isolated the logarithm. So now we're ready to convert to an exponential equation. The base is that little number next to the log, and the exponent is what the logarithm is always equal to. And what's inside the log function goes on the other side. But now we're kind of stuck. We don't know what to do because we have a fraction exponent. So we have to use log rule number 9, or excuse me, exponent rule number 9. Which tells us that that is equal to the square root of 3. Now this number here in red, that would be 2. But remember, when you have a 2 index, you don't write it. It's just considered to be square root without writing that. But if this denominator were a 4, you'd have to write 4 there. If the denominator were a 5, you'd have to write 5 there. Any other index than 2, you have to write it. But if it's just 2, you don't have to write any index in the root symbol. So now we can't really do anything with this. We could approximate that with our calculator, but we'd rather have the exact answer. So we're just going to keep it as root 3, add 1 to both sides, and then divide both sides by 4. And there you go. Let's try number 11. So again, we need to isolate the logarithm. It's not isolated because the 4 and the 1/8 are next to it. We need to get rid of that 4 and the 1/8. So we're going to subtract 1/8 from both sides. So we have 1/4 minus 1/8. We have to multiply both sides of this fraction by 2, so we get 2 over 8 minus 1 over 8. And you can see 2 minus 1 is 1, so we end up with 1/8. 1/8. Alright, so we've almost isolated the logarithm. Now all we have to do is get rid of that 4, so multiply both sides by 4. And we end up with 1/2. You end up with 4/8, but that reduces to 1/2. Again, 4 times 1/8, you write the 4 as over 1, multiply straight across. 4 times 1 is 4, 1 times 8 is 8, reduced to 1/2. Again, most intermediate algebra teachers are not going to tell you that. They're just going to expect you to know that. And if you ask them how to do that, then they're going to tell you you're in the wrong class. Okay, so obviously we're out of room. Let's put a divider up here. So we're going to, we've now isolated the logarithm. And we need to translate it to an exponential equation. So the base is 4, the power is 1/2, or the exponent is 1/2, whatever you want to call it. And so now we have to use an exponent rule. We're going to use rule number 9 again. And that tells us that that is equal to the square root of 4. And what is the square root of 4? What number times itself is equal to 4? Well, that's 2. And so now we're going to subtract 9 from both sides. And we get -7. Divide both sides by -2, and we get 7/2. So there you go. Okay, so let's try one more of these problems before you try one on your own. Again, we're going to isolate this logarithm. We're going to get it by itself. It's not by itself because the 4 and the 3 are next to it. Subtract 4 from both sides. And by the way, you can do two of these first steps in your head. You don't have to show this intermediate step. You can subtract 4, divide by 3 all in your head. Okay, I'm just doing this to be absolutely sure that you know what's going on. We're going to divide both sides by 3, so we have 2/3. And now the logarithm has been isolated. So the base is 27. We're going to translate to an exponential equation. The base is 27. The exponent is 2/3. And whatever's in the log function, that goes on the other side. So now we're stuck. Because we have a fraction exponent, we don't know what to do unless we use rule number 10 of our exponent rules. That tells us that the denominator of that fraction is the index of a root, and the numerator is the root raised to whatever the numerator is. Now remember, you can put that 2 inside. Instead of using parentheses, you could put it next to the 27 like so, but you know, it doesn't really matter which method you use for this particular problem. Okay, now it's very important to understand that cube root 27, what number times itself and then times itself again is equal to 27? Well, that's just going to be 3. So again, a number times itself again is equal to 27. So what number is this? 3 times 3 times 3 is 27. So we have that yellow cube root 27 turning into 3, and then that turns into 9. And let me find some more room here. So now we subtract 8 from both sides, divide both sides by 5, and we get x is equal to 1/5. Okay, so now it's time for you to try one of those types of problems. You can use 9, 10, 11, and 12 to help you. And when you come back, we'll do it together. All right, we're back. So we need to isolate this logarithm. It's not isolated because the 4 and the 2 are next to it. So we're going to subtract 2 from both sides. Let me move that down a little bit. And then we're going to multiply both sides by 4. And now we've isolated the logarithm. So now we just have to translate into an exponential equation. The base is that small number. The exponent is what the logarithm is equal to. And whatever's in the log function, that goes on the other side of the equation. 2 to the 4th power is 16. And subtract 3 from both sides, multiply both sides by 5, and we get 65. I did that kind of quickly in my head, so I'm going to double check that. 5 times 13 is 50 plus 15, that's 65, yeah. Alright, so if you got the right answer, good job. Let's try another one of those. I want you to try number 14. Now, be aware that for number 14, there's some things that we haven't done today. Actually, I think we did use rule number 10, but you're going to have to use rule number 10. And you're also going to have to use the distributed property. We haven't done that. That's where you multiply some number a times a sum. Remember, you multiply a into b and to c. So a times b, and then you add them together. You add the products together. So a times b, and then a times c, and then add the products together. If you get stuck, that's okay. We can do it together. But I want you to go ahead and try number 14. When you come back, we'll do it together. All right, we're back. So we need to isolate the logarithm. So we're going to subtract 2 from both sides of the equation. And then we're going to divide both sides by 8. And we've now isolated the logarithm. And before we go further, we should reduce this fraction here. We want to work with the smallest numbers possible to simplify things as much as possible. Okay, so we've isolated the logarithm and we've simplified that fraction. Now we have to translate to an exponential equation. So the base is that little number. The exponent is whatever the logarithm is equal to. And whatever goes on the other side, that's always what's in the log function. So now we're stuck. We don't know what to do because we have this fraction exponent. But remember, that's rule number 10. That tells us the denominator goes in the index of a root, and the numerator is whatever the expression is raised to. We're going to subtract. First of all, we can't do anything with this expression, so we're just going to leave it like that. We could use a calculator to approximate, but we don't want an approximate answer. We want an exact answer if we can. So we're going to subtract 6 from both sides. And here's the step where things get a little a little weird. We have to use the distributed property because we're subtracting two things, and we're going to multiply that difference by a number. So it's very important to understand you have to multiply this number by 3, and you have to multiply this number by 3. One of the most common mistakes that students make is they'll multiply this number by 3, but they will not multiply the 6 by 3. So when you multiply, you can just write that 3 right in front of the expression. And then 6 times 3 is 18. And I'm sorry, it kind of got scrunched in here. But that is the final answer. If you had a little trouble with that, that's okay. But now you know what that answer should be. If you got the right answer, then that's very good. Okay, I want you to try number 15. We're going to do a couple more of these before you try, or before we go on to something else. And when you come back, we'll do it together. All right, we're back. So we're going to add 1 over 16 to both sides. So we have negative 1 over 8 plus 1 over 16. Multiply both sides of this fraction by 2, and you get negative 2 over 16. Negative 2 over 16 plus 1 over 16 is negative 1 over 16. Again, that's all review. That's all stuff that you should know. A lot of students will complain and say, well, you didn't teach me that. Well, remember, there are a lot of prerequisites to this course. You're not allowed to take this course without taking arithmetic, pre-algebra, and beginning algebra. Those are the minimum prerequisites for this course. So now we're going to multiply both sides by 4. And negative 1 over 16 times 4, you just write 4 over 1, multiply straight across. Negative 4 over 16. So negative 4 over 16 is equal to log base 81 of 2 minus 7x. And we want to reduce this fraction if we can. Divide both sides by 4 and we get negative 1 over 4. So we've reduced that fraction. And again, the logarithm is isolated. So now we're going to convert to an exponential equation. The base is 81. The exponent is whatever the logarithm is equal to. And whatever's in the log function goes on the other side. Now at this point, we're stuck. We really can't do anything because we have a negative exponent. How do we interpret a negative exponent? Well, the log rules tell us how to do that. We're first going to use rule number 8. Which tells us that that negative power becomes a fraction. Then we're going to use rule number 9, which tells us that a fraction exponent becomes a root expression. And now we have to figure out what is the fourth root of 81. What number times itself, and then times itself again, and then times itself again is equal to 81. Well, if you think about that long enough, we can see it's going to be 3. 3 times 3 is 9, times 3 again is 27, times 3 again is 81. So it's going to be 3. So we have 1/3 is equal to 2 minus 7x. Subtract 2 from both sides. And we get negative 5 over 3. Divide both sides by negative 7. And we get 5 over 21. Now again, I can't show every single step of that arithmetic. I know some students will be saying, you know, you need to show us every single step of that, but we don't have time in this course. This is intermediate algebra, so we can't go back over arithmetic, pre-algebra, beginning algebra. You need to start to do that arithmetic on your own, but because you're in an upper math course, you should have the confidence at this point to be able to go back over that and learn that stuff on your own. Okay, so 5 over 21, if you got that answer, good job. I want you to try one more of these problems before we go on to the next thing we're going to learn today. Try number 16, and when you come back, we'll do it together. All right, we're back. So we need to isolate the logarithm as usual. So we're going to subtract 4 from both sides. And again, you can do these first 2 steps in your head if you want to. You don't have to show this intermediate step. Divide both sides by negative 14. Negative 7 divided by negative 14 is 1/2. And now we've isolated the logarithm, and we're going to translate it to an exponential equation. The base is 9, the power is 1/2. Whatever's in the log function goes on the other side, and now we're stuck because we have a fraction power. We don't know what to do with a fraction power. But rule number 9 tells us that that's equal to the square root of 9. What number times itself is equal to 9? That's 3. Subtract 2 from both sides, divide both sides by 6, and we get x is equal to 1/6. So if you got that answer, that's very good. Good job. So now we're going to solve logarithmic equations that require logarithm properties 5 through 7. Remember, in the previous class, we learned this property here that tells us that if you have a product inside a log function, you can change that expression into a sum of 2 logarithms. And if you have a fraction inside a logarithm, you can change that expression into the difference of 2 logarithms. And we're going to go over this rule here later on. But for number 17, it says solve without a calculator. Write the Roman numeral of each exponent rule or logarithm property that you use. So we have an x here, and we want to figure out what does x equal. Now what we could do is we could take this expression and put it on the other side of the equation, but we don't really know what this expression is. We could approximate it with a calculator, but we don't want to do that. We want to find the exact answer. And remember, we're told solve without a calculator. In order to solve this equation, we have to combine these logarithms. So we're going to use logarithm property 5, but we're going to go in the reverse direction. We're going to go from these 2 logarithms to 1 logarithm. And it's very important to understand that you can only do this if the bases in the logarithms are the same. If they were different bases, this wouldn't work. You see, it says here it has to be base k in both of these logarithms. So because they both have the same base, we can combine those using logarithm property of 5. And I'm going to write an L for logarithm property because we're using exponent rules and logarithm properties, and we're using Roman numerals for both of those. I thought about using a different numbering system, but I think Roman numerals are the best. So I'm just going to say L5, which means logarithm property 5. And that tells us that we can combine those 2 logarithms to 1 logarithm, but what's in these logarithms is now going to be multiplied. You see a times b. So it's going to be 5 times x inside the logarithm. Now, we don't want any confusion whatsoever. We don't want you to think that this logarithm is multiplied. The entire logarithm is multiplied by x. We don't want you to think that. So we're going to write parentheses here, and that shows us that both the 5 and the x are in the log function. And so again, just to be clear, we combine these 2 logarithms into 1 logarithm down here. And now we just solve as usual. We have 1 logarithm. It's isolated on one side of the equation, so we translate to an exponential equation. The base is 4, the exponent is whatever the logarithm is equal to, and whatever's in the log function goes on the other side. 4 to the 2nd power is 16. Divide both sides by 5, and we get 16 over 5. Okay, so let's try another one of these problems. You can take a screenshot of these if you want to, or it's better to just take a picture with your phone so you can look at your phone while you're doing these problems. So we're going to do the same thing here. We have to combine these logarithms, but now we have subtraction. We're subtracting those logarithms. So we're going to use logarithm property 6, L6. When you're subtracting, logarithm property 6 tells us that you divide. At the left there it says you change into a fraction, so it's going to be x over 4. And it's very important to understand that the number inside the logarithm that you're subtracting, that always goes in the denominator. If you write 4 over x, then that's going to be wrong. And also, be aware that these bases must be the same, or else we cannot use that rule. We cannot combine those logarithms. So now, we're going to translate to an exponential equation. The base is that small number. The exponent is what the logarithm is equal to. Whatever's in the log function goes on the other side. And now we just solve this equation. We're going to use exponent rule number 6. Just to show you we're using the exponent rule. I'm writing E for exponent rules because we have logarithm properties and exponent rules. Anything raised to the 1 power is just whatever the number is. And multiply both sides by 4, and we get x is equal to 12. All right. So again, we're using logarithm properties 5 and 6 to solve these equations. We'll use 7 later on. Let's try a couple more of these before you try one on your own. Sorry, the program is dancing around. So we need to combine these logarithms to simplify the equation. So we're going to use logarithm property 5 because we're adding the logarithms. And the constant usually goes first, even though y is at the left. Usually we write left to right, but the constant usually goes first when you write a product. And so now we're just going to translate to an exponential equation. The base is that little number. The exponent is whatever the logarithm is equal to, and whatever is in the log function goes on the other side. And exponent rule number 7, E7, tells us that anything raised to the 0 power is 1. And divide both sides by 4, and we get y is equal to 1/4. All right, let's try one more of these problems. So now we have subtraction. We're subtracting these logarithms. So we're going to use log rule number 6, L6. So we end up with log base 2 of b over 3. When you're subtracting the logarithms, you write a fraction inside the logarithm. And the base is 2. The exponent is whatever the logarithm is equal to. And 2 to the 5th power, that's kind of a big number, but that's 32. Multiply both sides by 3, and we get 96. All right. So now it's time for you to try. I'm going to leave number 19 and 20 in the window. Go ahead and try number 21. Remember, these bases are the same, which means that we can use logarithm property 5 and combine these logarithms, and that'll make the equation simpler. So try number 21, and when you come back, we'll do it together. All right, we're back. So using logarithm property 5, we're going to combine those logarithms into one logarithm. And when you're adding logarithms, you have multiplication. And now we're going to translate. The base is that small number. The exponent is whatever the logarithm is equal to. And then we're left with 3x on the other side. 6 squared is 36. Divide both sides by 3. And x is equal to 12. So if you got that answer, good job. All right, try number 22. You're going to need to use logarithm property 6 because we're subtracting the logarithms. And when you come back, we'll do it together. Remember, these are the log rules. You can take a picture of those with your phone if you need to. Go ahead and try number 22. All right, we're back. We're going to use logarithm property 6 to combine those logarithms. And then we're going to translate to an exponential equation. And 2 to the third power is 8. Multiply both sides by 10. And y is equal to 80. So if you got that answer, good job. Go ahead and try number 23. And when you come back, we'll do it together. All right, we're back. We have the same base, 4 and 4, so we're going to use logarithm property 5 to combine those to one logarithm, and whatever's inside becomes a product. Then we're going to translate to an exponential equation. The base is 4, the exponent is whatever the logarithm is equal to, and rule number 7 tells us, exponent rule number 7 that is, tells us that anything raised to the 0 power is 1. Divide both sides by 9, and we get x is equal to 1/9. If you got that answer, good job. Go ahead and try number 24, and when you come back, we'll do it together. All right, we're back. So we're going to use logarithm property 6, which tells us to combine and we combine to a fraction because we're subtracting the logarithms. And now we just have to translate to an exponential equation. Anything raised to the first power, exponent rule number 6 tells us that it's just that number. Multiply both sides by 2, and we get 14 is equal to b. So if you got that answer, very, very good. Good job. So now we have problems that are a little more complicated. As you can see, we have two logarithms, and they both have the same base. But the problem is we can't combine these because we have these coefficients here. You see, logarithm property 5 tells us that we can add logarithms that don't have coefficients. But if we have coefficients here, the property doesn't tell us that, you know, if we have coefficients here, then somehow we can combine the logarithms. It doesn't say anything about the coefficients. So we can't use logarithm property 5. So what do? Well, we need to somehow get rid of these coefficients so we can use logarithm property 5. And in order to do that, we're going to use logarithm property 7. This property tells us that if we have a power inside a log function, we can take the exponent and throw it in front. It becomes a multiplier of the logarithm. We're actually going to be going in the opposite direction. We're going to be going from here to here. We're going to take the coefficient and throw it up into the, it's going to become the exponent of that power. So again, you can take screenshots or a picture with your phone of these. So what we're going to do is we're going to take this 2 and we're going to throw it up, and it's going to become the exponent of x. So we have log base 4 of x to the second power. And we're going to do the same thing with this 3. We're going to throw it up, and it's going to become the exponent of that logarithm. And that is logarithm property 7. So now, at this point, we can use logarithm property 5 because we're just, adding 2 logarithms. We're not adding logarithms that have coefficients, you see. Now we can use logarithm property 5 here. Again, there's no coefficients here on the logarithms. We had coefficients, and but we got rid of these coefficients by throwing them up into the exponent, or they became an exponent. So now we're going to use logarithm property 5. So we have log base 4 of x squared, and actually, you know what? Before we use log base or the logarithm property 5, I'm going to change 2 to the third power to 8. I'm just going to simplify that. And then we're going to use logarithm property 5 and combine those logarithms. And usually the constant goes first in that product. So we're going to write the 8 first. And it's always good to use parentheses so we know what exactly is in the log function. And now we're going to convert to an exponential equation as usual. The small number is the base, the exponent is whatever the log is equal to. And so 4 to the third power, that's going to be 64. And we want to divide both sides by 8, and we get 8 is equal to x squared. So we found x squared. Problem is we don't want x squared. We just want x. So we're going to have to square root both sides to get rid of that square. And remember, when you have an even power, you always have to write plus or minus. And that becomes 2 root 2 on the left side of that equation. Now again, this is stuff that we went over in previous classes in this course, but you can change root 8 to 4 times 2. Then we learned that principle where the root of a product becomes the root of one factor times the root of the other factor. Root 4 is just 2, and then you can get rid of the dot. So this is just all review. You're expected to know how to do that. You can go back to my class on roots if you need to review that. So we have 2 solutions. We have positive 2 root 2, or we have negative 2 root 2. Now, we need to stop here. It's very important to understand that you cannot have a negative number as the base of a logarithm. That's a tradition. And you cannot have a negative number in the log function. So we're not allowed to have a negative number in there, so we're going to write x is not equal to negative 2 root 2. So 2 root 2 is the answer. So that was an extraneous solution. Okay, let's try number 26. Now the problem is we have a coefficient here, so we can't use property 5. All right? So we have to use property 7 to take that coefficient and throw it up into the log function, and it becomes the exponent. And so now we can use log property 5, or log property 6 actually. So that was log property 7. So let's go ahead and simplify. You can do this in your head. You don't have to write an extra step. Let's simplify 3 to the 4th power. That's 81. And now we're going to use logarithm property 6 to combine the logarithms. And be sure to write parentheses so you know what's in the log function. And Now we want to convert to an exponential equation. So the base is the small number, the exponent is whatever the logarithm is equal to. And now we have to use exponent rule 7. So we're going to write E7. Anything raised to the 0 power is 1. Multiply both sides by 81, and we have 81 is equal to y. So again, we're just using logarithm properties 5 through 7. Let's try a couple more of these before you try one on your own. We want to combine these logarithms, but we can't do it because these coefficients are here. Logarithm property 5 doesn't say anything about coefficients, you see. So we're going to have to use logarithm property 7 first. Take that 2 and throw it up into the log function as an exponent. Take that 3, throw it up. It becomes the exponent inside the log function. And again, you don't have to show this extra step, but I'm just going to simplify that. 2 to the second power becomes 4. And now we can use logarithm property 5. We're adding. So when we combine, we multiply 4 times x cubed. And now we're ready to translate to an exponential equation. The base is 125. The exponent is whatever the logarithm is equal to, and whatever's in the log function goes on the other side. Now we have to use exponent rule 9, and that tells us that the fraction exponent becomes cube root 125. And what number times itself, and then times itself again, is equal to 125? Well, that's going to be 5. So 5 is equal to 4x cubed. Divide both sides by 4 to isolate the x cubed. And we found x cubed. Problem is we don't want x cubed. We just want x. So you're going to have to cube root both sides to get rid of that cube, or that third power. And it's very important to remember that this is an odd exponent. When you have an odd exponent, you don't have to write plus or minus over here. And that's it. We can just leave our answer in that form. We could approximate this, but we want the exact answer. Okay, let's do one more of these before you try one on your own. We're just getting used to using these logarithm properties to solve equations. So we'd like to combine these logarithms to simplify this equation, but we can't do it. We can't use rule number 6 because of these coefficients. So we're going to take those coefficients and throw them up into the log function. The 2 and the 4 we threw up into the log function. And that was logarithm property 7. Now we're just going to simplify. 2 to the 4th power is 16. And now we're going to use logarithm property 6 to combine the logarithms. And we have y squared over 16. Make sure to write parentheses. Then we're ready to translate into an exponential equation. The base is 5. The exponent is whatever the logarithm is equal to. And whatever's in the log function goes on the other side. Then we're going to use exponent rule 6. Anything raised to the 1 power is just whatever the number is. And now we have an equation with a square. We're just going to isolate the square. multiply both sides by 16, and you get 80. And we found y squared. Problem is we don't want y squared, we just want y. So you have to get rid of that square. We're going to square root both sides, and it's an even exponent, so remember you have to use plus or minus symbol. And we're left with y is equal to plus or minus root 80. But remember, you have to pull out a perfect square if you can. And we know that 80 is 16 times 5 because we just multiplied 16 times 5. And the reason that that's interesting to us is because 16 is a perfect square. So 16 is going to come out as a 4. Square root of 16 is 4. And the 5 stays inside. So we have two solutions. We have positive 4 root 5. And we also have negative 4 root 5. But there's a problem. We can't have a negative inside the log function. Remember, we talked about that. You cannot put a negative number inside a log function. That's not allowed in mathematics. So this is really not a solution. That's an extraneous solution. And we rectangle the one at the left. And there you go. All right. So now it's time for you to try. We have 2 more problems, actually 4 more problems today. You can take screenshots of all the problems that we did. You can take a picture with your phone. Actually, that would be better. And now it's time for you to use logarithm properties 5, 6, and 7 to solve these equations. So I want you to go ahead and try number 29. Remember, the first thing you have to do is use logarithm property 7 to take that coefficient and throw it up into the log function. Then you can use rule number 5 because we have addition. Try number 29, and when you come back, we'll do it together. All right, we're back. I'm going to use logarithm rule 7. And that becomes log base 3 of 2 to the 4th power. And then I'm just going to simplify. 2 to the 4th power is 16. And then I'm going to use logarithm property 5. And then I'm going to translate to an exponential equation. And then we need to use exponent rule 6, actually 7. That tells us that anything raised to the 0 power is just 1. Then we divide both sides by 16, and we end up with 1 over 16 is equal to y. And there you go. So if you got that answer, good job. Be sure to write your the numbers of the exponent rules and logarithm properties as you do this. Go ahead and try number 30. Remember, we can't do anything unless we first put these coefficients up into the log function. They become exponents. So use logarithm property 7 before you do anything else. So try number 30, and when you come back, we'll do it together. All right, we're back. So we're going to use logarithm property 7. The coefficient goes up into the becomes the exponent. Same thing on the other logarithm. So now we're going to simplify. 2 to the 5th power is 32. And now we're going to use logarithm property 6 to combine the logarithms. And remember, when you're subtracting the logarithms, the expression in the combined logarithm is a fraction. And whatever's in the logarithm that you're subtracting, that goes in the bottom, always in the bottom. Okay, so now we're ready to translate that into an exponential equation. The base is that small number. The exponent is whatever the logarithm is equal to. And whatever's in the log function, that goes on the other side. And now we have a fraction exponent. So we're going to use exponent rule 9. And that becomes the square root of 4. And of course, the square root of 4 is 2. And now we just multiply both sides by 32, and we get 64 is equal to b to the 6th power. Now that looks like a difficult equation to solve, but it turns out that 2 to the 6th power is 64. So we can just 6th root both sides. And it's an even exponent, so remember you have to write a plus or minus. And so we end up with b is equal to plus or minus 2, because 2 times 2 times 2 times 2 times 2 times 2 is 64. I know that's kind of a difficult thing to deal with, but if you got stuck on that, that's okay. Now remember, we can't have a negative number inside a log function, so b cannot be a negative number. So we're going to say that b is equal to 2, but b cannot be equal to negative 2. So that negative 2 is an extraneous solution. All right. So go ahead and try 31. We have 2 more of these problems to do before we're done today. Try 31, and when you come back, we'll do it together. All right, we're back. So we're going to use logarithm property 7 to throw those coefficients into the log functions. And then we can just simplify. 3 to the 4th power is 81. Now we're ready to use logarithm property 5 to combine those logarithms. When you're adding the logarithms, it becomes a product inside the combined logarithm. And now we're ready to translate to an exponential equation. The base is 9. Whatever the logarithm is equal to, that's the exponent. And whatever's in the log function, that goes on the other side. And 9 squared is 81. Divide both sides by 81, and we get 1 is equal to x squared. So we found x squared. But we don't want x squared. We just want x. So we have to get rid of that square on the x, so we square root both sides. And the square root of 1, what number times itself is equal to 1? Well, that's just 1. 1 times 1 is 1. So x can be 1, or x can be negative 1. Problem is, again, you can't have a negative number inside a logarithm. It can't be in the function here, and it can't be the base either inside a log expression. So x cannot be equal to negative 1, but x is equal to 1. So again, that's negative 1 is an extraneous expression, or extraneous solution. So if you got number 31, good job. All right, go ahead and try number 32, and when you come back, we'll do it together. All right, we're back. So we're going to use logarithm property 7 and throw those coefficients up into the log function. And then we're going to simplify. And then we're going to use logarithm property 6 because we're subtracting the logarithms. So that's going to be m to the 5th over 25. And now we're ready to translate to an exponential equation. The base is 2. The exponent is whatever the logarithm is equal to. And whatever's in the log function, that goes on the other side. So now we need to use exponent rule 6, which tells us anything raised to the first power is just whatever the number is. And now we just have to isolate that m to the 5th. And so we're going to multiply both sides by 25. And we get 50 is equal to m to the 5th power. And so we found m to the 5th power. But we don't want m to the 5th power, we want m. So we're going to do the opposite of raising to the 5th power, which is 5th rooting. And this is an odd exponent, so we don't have to write a plus or minus sign on the 5th root of 50. And so that gets rid of the 5 power, and we're left with the 5th root of 50. And there's nothing really that we can do. There's no perfect 5th power in here. So we can just leave that like so. So if you got that answer, good job. Okay, now we're going to solve problems that have 3 logarithms. You can see we have 1, 2, 3. But remember, we know how to condense 3 or 4 or 5 or any number of logarithms. We're going to use logarithm property 7 because we can't condense them unless we get rid of this coefficient first. Remember that. So you're going to bring 2 up. And it becomes the exponent. And there's different orders that you can do this. You could actually combine these 2 logarithms first if you wanted to, because those don't have coefficients. So you could combine those first if you wanted. But I'm just starting with rule number 7. So now I'm just going to simplify. 5 to the 2nd power is 25. Again, you can skip some of these steps if you want to. You don't have to show every one of these. And now we're ready to use logarithm property 5 because you're adding logarithms. So I'm going to combine the first 2 logarithms. You can do it in any order you want, really. And you could just combine all 3 of these logarithms at once. I don't really require you to do this with quite so many steps. But I'm just doing this to be absolutely sure that you know what's going on. Because logarithm property 5 doesn't really say anything about combining 3 logarithms. It just says you can combine 2 logarithms. So I want to be clear what's happening here. So now we're going to use logarithm property 5 again to combine these 2 logarithms. And again, the only reason we can do this is because we have the same base 2 on all these logarithms, you see. So I'm just showing that multiplication with a dot there. Again, you don't have to show that intermediate step with a dot. You can just go ahead and multiply them. But I'm just being very thorough here, showing you what's going on. 25 times 3 is 75, and x times x is x squared. And whoops, I forgot to write my equal sign. and 3. So now, do you agree the equation is much simpler? So now we want to translate to an exponential equation. So we write the base, and the exponent is what the logarithm is equal to, and that power is equal to the expression in the logarithm. 2 to the third power is 8, and we're going to divide both sides by 75 because we want to isolate the square, and we found x squared. But again, we don't want x squared, we just want x. So we're going to do the opposite of squaring, which is square rooting, and because it's an even exponent, you need to use a plus or minus symbol. And now we have to do some math that we learned in previous classes. I know you don't want to have to do this, but we have to simplify this expression. Mathematicians don't allow us to keep it in this form. Remember, if you're square rooting a fraction, you just square root the numerator and the denominator, and you can deal with those roots separately. Now, it's easier to take out the perfect squares first. So 8 is 4 times 2. The 4 comes out as a 2 because it's square rooted, and the other 2 stays inside. 75 is 25 times 3. And the 25 is a perfect square, so it comes out as a 5, and the 3 stays in. And at this point, I'm going to find some more room. We pulled out the perfect squares, and now we need to get rid of that root in the denominator. Remember, we can't have a root in the denominator. So you're going to multiply both sides of this fraction by root 3. So root 2 times root 3 is root 6, and root 3 times root 3 is 3, and then you have 5 times 3, and you don't really have to show every single one of these steps, so you're not going to have as much trouble fitting everything into the page. But we end up with 2 root 6 over 15, plus or minus. Forgot to write my plus or minus symbols. But we suspect, as usual, that we're not allowed to have a negative x. And let's look up in here and see if we're allowed to have a negative x, and we can see if you have a negative x in any one of these logarithms, then you have a negative inside that logarithm, so we're not allowed to have a negative, so we can just get rid of that plus or minus symbol, and that is the final solution. Okay, so I want you to try number 34. You can use number 33 to help you, and when you come back, we'll do it together. Alright, we're back. So again, you can use rule 7 first, or you can combine both of these logarithms with rule 5. There's multiple ways that you can do this. I'm going to use rule 7. That's going to put that 3 coefficient up into the, it's going to turn it into the exponent. And I'm just going to simplify that logarithm. Two to the third power is 8. And then I'm going to use logarithm property 5, of course. Logarithm property 5 to combine the first two logarithms. Now again, you can combine in any order you want. You can combine the first two, or the second and third logarithm, or the first and third logarithm, doesn't matter. But I'm going to combine these first two. So we have log base 5 of 8y squared, and you want to use parentheses just to be clear that all of that is inside the log function. Now we're going to use logarithm property 5 again. So we have log base 5 of 8y squared times 3. And simplifying, we have log base 5 of 24y squared. And now we need to translate to an exponential equation. The base is that little number, the exponent is what the logarithm is equal to, and whatever is in the log function goes on the other side. Divide both, well, we're going to simplify first. So we have 25 is equal to 24y squared. Divide both sides by 24, and we get 25 over 24 is equal to y squared. We found y squared, but we don't want y squared, we just want y. So we're going to square root both sides. Remember, it's an even exponent. 2 is an even exponent, so you have to write a plus or minus symbol. And so we have y is equal to, and remember, when you're square rooting a fraction, you just square root the numerator and divide by the square root of the denominator. And lucky for us, the square root of 25, well, that's just going to be 5. And we're going to have to do two things here. We're going to have to pull out the perfect square, and we're going to have to get rid of the root completely in the denominator. Now you might say, well, can't we just multiply both sides by root 24? We can do that, but we're still going to have to pull out the perfect square. We're used to just pulling out the perfect square in the first step, so I'm going to go ahead and do that. Again, when you don't have room, don't panic. Just use an arrow. 24 is 4 times 6. The 4 comes out as a 2. The 6 stays inside. Multiply both sides by root 6, and you get 5 root 6 over 2 times 6, because root 6 times root 6 is just 6. Again, this is all review. If you're rusty on this, you can go back to my classes on roots in this course. And then the final step is 2 times 6 is 12. But as usual, remember, if you actually in this case, y can be positive or negative. Now listen to me. If you said y can only be a positive, that's okay. But this problem is a little bit different. So if you missed the negative, that's okay. But the reason that y can be positive or negative is because it doesn't matter if it's positive or negative. If you plug it in here, you square it, you get a positive. You see? So because you always end up with a positive in the logarithm, your answer can be positive or negative. It's not going to create any kind of problem. Now, these logarithms don't have a y, so we don't really care about those. If you had 2y here, then that would be a problem. You can't have a negative. If you had 3y to the third power means if you square a negative, you get a negative. So we'd have a negative in here. We're not allowed to have that. But the only y appears in this logarithm, and if you square it, it doesn't matter if it's a negative. It just becomes a positive. So it's not going to create a problem in this equation. So that was kind of a weird one, because normally we can't have a negative. So I'm not trying to fool you or anything, but that was kind of a weird problem, because in this instance we can have a positive or negative. So I'm sorry I gave you kind of a trick one there. But if you got 5 root 6 over 12, then you're on the right track. You have what you need. All right, so if you got that answer, good job. Let's try number 35. So the difference here is now we have 3 logarithms, but we have subtraction and addition. So we're going to have to use logarithm property 6. The first thing we want to deal with is the coefficient, so I'm going to use logarithm property 7. Again, you don't have to do that. You can use logarithm property 6 on these two first if you want to. Sometimes you do have to do things in a certain order, but you could use 6 first. Now, please be aware that you cannot use logarithm property 5 here. That does not work. And the reason it doesn't work is because this has a negative coefficient on it. So just be aware of that. Simplifying, 2 to the third power is 8. And now I'm going to use logarithm property 6. I'm combining these two logarithms. So we get b squared over 4. It's always good to go back and check, make sure everything looks right. Now we're going to use logarithm property 5. And that's going to combine these two logarithms. So we have b squared over 4 times 8. Now remember, when you're multiplying a fraction, by a whole number, you just write that whole number over 1, and you just multiply straight across. 8 times b squared and 4 times 1. So we end up with 8b squared over 4, and 8 divided by 4 is just 2. So you don't have to show this intermediate step. If you can get to 2b squared in your head, that's completely fine. You're not required to show that in intermediate algebra. I'm just taking it step by step so you know exactly what's going on here. So at this point, you can see we've simplified the equation quite a bit, and now we're ready to convert to an exponential equation. And we're going to use exponent rule 6. Anything raised to the first power is just whatever that number is. And then we're going to isolate the square. So we have 9/2 is equal to b squared. So we found b squared. Problem is we don't want b squared. We just want b. So we have to do the opposite of squaring, which is square rooting. And remember, when you're square rooting a fraction, you always square root the numerator and divide by the square root of the denominator. So we have 3 over root 2 is equal to b. But we're not allowed to have a root in the denominator, as you know. So multiply both sides by root 2, and we get plus or minus 3 root 2 over 2 is equal to b. And are we allowed to have a negative in the logarithm? And here you can see that we actually are allowed, because it doesn't matter if it's positive or negative. It's just going to square this, and it's going to end up being a positive inside the logarithm. Over here we don't have b's, so we don't really care. So the final answer, plus or minus 3 root 2 over 2. All right. So I want you to try a problem like that. This is going to be the last problem for the day. Go ahead and try number 36. And when you come back, we'll do it together. All right, we're back. So I'm going to use logarithm property 7. In this case, you could use logarithm property 5 first if you wanted to, and combine these first. That would be fine. I'm going to go ahead and simplify just to be absolutely clear what's happening here. 3 to the 4th power is 81. And now we can use either logarithm property 6, or we can use logarithm property 5. So I'm going to use logarithm property 5 to combine these two. Maybe I should move that down a little bit. So we have log base 4 of x times 3x. And just rewriting the other stuff. And then we have logarithm property, or logarithm base 4 of 3x squared. Simplifying. And now we can use logarithm property 6 because we have subtraction. So we have log base 4 of 3x squared over 81 equals 0. Now we're ready to translate to an exponential equation. Anything raised to the 0 power, exponent rule 7 tells us that that just equals 1. Now we have to isolate the x squared expression, so we're going to multiply both sides by 81. Then we're going to divide both sides. Actually, you know what? Before I even do that, probably should just reduce. Well, I guess I'll just keep going. You can actually reduce that fraction, but I'm going to go ahead and divide by 3, and 81 divided by 3 is 27. We could have done that earlier if we wanted to, but... Okay, so we found x squared. We're getting close. But remember, you don't stop there. We don't want x squared. We're not looking for x squared. We're looking for x. So square root both sides. And we have x is equal to, and 27 is 9 times 3. 9 is a perfect square. It comes out as a 3, and the other 3 stays inside. Now, are we allowed to have a negative in the logarithms? And the answer is no, because if you plug these a negative into these x's, you're going to get a negative inside the log expression. Over here, we didn't care because if you have a negative, well, this square is a negative and it becomes positive. So it doesn't matter if you have a positive or negative. The actual number after squaring inside the logarithm is positive no matter what. So the answer was plus or minus. But down here, we're not allowed to have a negative, so we just say that the final answer is 3 root 3. So if you got that answer, that's very good. Okay, let's go ahead and take screenshots of all the work that we did today to help you with your homework or to study for tests. Here's screenshot number 1 and screenshot number 2 and number 3 and number 4 and number 5 and number 6 and 7 and 8. And don't go before you get your homework. Let's take a look at the homework. So here's screenshot number 1 for the homework. And we have one more problem down here you can take a screenshot of. So remember, if you don't do that homework, you're just not going to have the fluency that you need to be able to read and write mathematics. You have to actually do practice problems, every single one that I tell you to do. Don't just do half of these and say, well, I've got it. No, you don't have it. Do every single problem. These 19 problems are the minimum that you need to learn this material. So that said, I'll look forward to seeing you in the next class.